Imco Total Wear Solutions.
So last time we discovered what Imco does for the sugar industry. I was sitting down with Mahesh where he kind of explained the kind of solutions that you were giving to the sugar industry. Something I came across on your website was that you all offer solutions for the mining industry as well, right? My question is that are the types of wear that, what are the types of wear that the mining industry goes through?
So majorly when you mine the ore from the quarry, these are in big boulders.
Right.
So they have two types of crushings which are involved in this mining industries.
Right.
So primary crushing is the one that is in the mine area where the first boulders come and they start getting crushed into from a lump of almost 1 meter.
So
plus.
Just to clarify, so when we're saying mining, we're talking about mining iron and ore for the steel industry.
Yeah.
Right.
Mining as general.
Mining as general.
As
Okay.
general.
Okay. Got it.
So it can be mining of iron and ore. It can be coal. It can be copper.
Right.
It can also be lithium.
Right.
Nickel.
Right.
So every ore has got a different properties.
Right.
And every ore behaves also in a very different manner. So the wear patterns for all these minerals are different. So that depends upon A, hardness of the ore, B is how abrasive the material is, and C is that is there any kind of moisture or something in the mine, in the ore. So when we talk about iron ore as specific, so they whatever is ored from the mines comes in boulder forms, which are excavated. First it is blasted, then it's excavated by these excavators, and then they get into the dump bodies, dumpers, and then they come and get dropped into the first primary gyrators.
Right.
So the gyrators are supposed to be the first process of crushing.
Okay.
That means it's like a pendulum effect where the center pendulum is rotating, is oscillating, and the big ores like 1 meter boulders come and fall into it.
So the big boulders are getting crushed between the arm and the wall of the gyrator.
The wall of the gyrator and the pendulum.
And the pendulum, right.
Yeah. So it is like a pendulum really rotating.
Right.
And because of the heavy
the mass
of the pendulum and the wall, the ore gets crushed, and the input of 1 meter or above becomes 200 to 400 lumps.
Right.
So this is the first stage of the primary crushing, and then when it passes through a stage of what we call it as grizzly bars.
Okay.
Where these lumps get separated.
Okay.
So the bigger ones are recycled back into the gyrator.
Okay.
And the smaller one, like for example 200 to 300 millimeters, goes down. And there they are conveyed to the secondary crusher.
Right.
So the secondary crusher is again divided into 3 or 4 parts. So right from 400 millimeter size or 300 millimeter size of an ore, it reduces to almost -3. So the final stage of the secondary crusher would be a very micron-sized ore. Now this ore is transported to the steel plant.
Okay.
So that is the final ore.
Right.
And at every stage that it is crushing, it has got different crushing equipments.
Right.
Which gets finer and finer and finer.
So
this is the job of the mining company.
So through this primary and secondary crushing process, what is the main type of wear that not only the gyrator but other machines as part of this process, what is the type of wear that they are undergoing?
So in the stage 1, it is depending mostly on the ore material. So for example, an ore which we get in Odisha might be different from the one that we get in Bacheli or in NMDC.
Okay.
It is all naturally been formed.
Occurring materials, right?
So there are different types of percentage of Fe, that is the iron content, which gives this wear quality or the wear properties. So the wear properties, I mean, if you talk about what type of wears it occurs to, so it mainly have abrasion,
Right.
and the fall from wherever it is falling is leading to impact.
Right.
And it does contain moisture, and if it contains more moisture, then there is a corrosive effect
Right.
which takes place.
Right. Right.
Because any moisture in these kind of ore leads to a clay formation,
Right.
and the clay formation becomes sticky,
Right.
and the stickiness leads to sticking of material on the walls of these crushers, which solidifies due to oxidation, and then it becomes like a hard rock again
Right.
in the process. So these are the three major factors that leads to wear in this all this equipment. A is the abrasion, because it's an abrasive media.
Right.
P is the impact because of its fall, and C would be the moisture content or the wet condition which leads to the corrosive atmosphere.
So these are the three main.
But
types
there is
of-
one more type which is also called as a dry crushing. The dry crushing is basically once the moisture is completely removed or dehumidized, and then it becomes dry. So there it is more of impact, abrasion, and some percentage of erosion. So
Right.
this is the classification of the
Right.
wear.
So, I mean, one thing that that stood out in what you said was that these are naturally occurring materials, right? And ore you might find in Orissa as compared to somewhere in Bracheli would be very different, or an ore from and would vary from different parts of the world, right? So, I mean, how does this affect efficiency in mining?
Every crushing unit witnesses its own typical wear pattern.
Okay.
So it is not easy to get defined whether this is the wear pattern in this particular mine in Joda or in Nomonti. It would be the same in the same area which has an area called Khonbon.
Right.
Khonbon ore is highly abrasive
Right.
because it has a very nearby manganese ore touching the same area. So that ore is highly abrasive, and the ore in Joda or in Bacheli might be less abrasive. So the answer to the question is that it is very difficult to give a wear solution based on these kind of wear patterns. But now as we are graduating to more and more technology, definitely these solutions are arising.
Your company Imco caters to the mining industry. Is efficiency a major factor in mining? I mean, I ask from the point of view that when we spoke to Mahesh, who is catering to the sugar industry, sugar being a seasonal business, they were operating, the factory only operates for, let's say, 4 to 5 months in a year. So efficiency is really important for them. They can't afford to take any kind of shutdowns, or they can't afford any kind of downtime, right? Mining being a 12-month industry, how important is efficiency in this industry?
See, any process line, efficiency is always the most prime factor, because any kind of downtime leads to losses.
Right.
So even if it is a 12-month or a 6-month, so whenever there is a downtime involved, say for example changing of these liners, so the entire process line stops, because they cannot just change one segment by bypassing the other lines.
Right.
So that is a downtime, and downtime means an entire loss for that day. So whatever is the cost of the ore multiplied by number of hours lost, that is enormous.
Huge.
it is something by which the cost factor cannot be defined compared to what is the cost of the equipment in that particular ratio.
Right.
So no company wants downtime.
Right.
If you ask me, any mining company would ask that, can you give me 12 months life?
Right. Right.
So they would always like to avoid any kind of shutdown, and this is a huge cost to the company. So pro rata, it is very negligible what is the cost of the equipment or the liner that you are changing compared to the loss per day.
In terms of offering solutions for the mining, I mean, can you just tell me a little bit about what are the kind of products that you offer for the mining industry?
So iron ore is a much harsher mineral or a rare earth material compared to coal. And India being a very large iron deposit country, there are two major players who are operating these mines.
Right.
One is Tata,
Right.
then you have NMDC,
Right.
which is a government run organization, and of course we have SAIL, which has its own deposits,
Right.
and then JSW and all also have
Right.
own deposits, and then there are some smaller players who also have these deposits. They are very old deposits, like maybe more than 200-300 years old.
Right.
But it is only after Jamshedji Tata discovered, after going to England, that steel has been invented, and this is what is the use of this iron ore, that India started looking into exploring this activity. Now, once this was done, then the factors in last 50, 60, 70 years, they have also learned through the curve that the downtime can be reduced by using better liners.
Right.
So previously they were all using mild steel fabricated.
So, I mean, just for our audience to understand, can you explain what a liner is? When you say liner, what do you really mean? And not what a liner, I mean, also what a liner is in an easy manner, and also what is its application in when it comes to primary or secondary crushing in mines?
So when you take a design of a crusher, the crusher is designed in a manner where you have a hopper or a transfer line or a duct,
Right.
or an elbow
Right.
through which this material is passing.
Right.
So when this abrasive material passes through any of these chute, transfer lines or duct or hopper,
Yeah.
it is rubbing against the wall
Right.
of the base material.
Right.
And this material being abrasive,
Right.
due to this continuous abrasion or the material rubbing against each other, it leads to very excessive wear on a substrate which is less harder than the ore. So you can imagine, once it starts rubbing, something is very hard and the substrate or the substance back support is very
it'll
soft.
start wearing out the base metal.
It not only starts wearing out, it eats it up.
Okay.
And at one point there will be a hole.
Okay.
And that hole, not one point, it will be very fast, within a day.
Right.
And that hole is leading to leakage.
Right.
That's a stoppage.
Right.
So they used to put a patch.
Right.
And the patch used to again get worn in 2 days.
Right.
Then they used to put another patch. That again used to get worn out in 3 days. So there was no way that they could stop this wear from occurring, this natural wear.
Right.
So the question and the solution for liners came into the picture.
Okay.
So if you support that same wall with a 10 or 20 millimeter hard liner,
Right.
which is consisting of very hard chromium carbide particles. So these carbides at a 60-62 HRC hardness should give you a much better life compared to what the base metal mild steel plates used to be given.
Right.
From there, the invention and the start of liners started coming in.
Okay.
So previously they were using some material called hardox, which was about 35 to 40 HRC.
Right.
That could again give way because it could not take such high abrasion.
Right.
Then they graduated into using some kind of wear plates, hard welded plates. Again, that gave up because the welding has lot of inner defects, porosities,
Right.
and these particles travel through them and then they create a hole. Again,
Right.
it's a downtime. So gradually it has evolved in this last 40 or 60 years that from mild steel plate to hardox plate to a wear plate to this special sinter cast liners.
Right.
That is what we are giving them now as a solution.
Right.
Graduating towards that, now we have also invented the ceramics and the composite ceramics and the metal matrix ceramics. Now this is where the evolution is changing, and we are finding that these are again giving them much better life compared to what this chromium carbide, sintered carbide liners are also giving.
Right. So from what I understand is that the liners are helping extend the life of the chutes, hoppers, elbows, anywhere through which this material was passing, right? So the idea is that, I mean, from what you're saying is that the cost of replacing an entire chute as compared to just replacing the liner is way cheaper than compared to also the downtime that they would face, right? So that is, I mean, what is really the advantage that we are seeing of using, I mean, let's say advanced ceramic or an advanced liner as compared to a cheaper mild steel solution?
So if you consider a hopper or a transfer line or a chute, so these are not small fabricated items.
Right.
They can stretch up to almost 6 to 8 meter long or 10 meter long at a stretch. So just changing that with a replacement, which again could wear out after 3 days, makes no sense.
Right.
Now what are we looking at? We are looking at a life factor that can be enhanced in such a manner that from 2 months it goes to 4, from 4 it goes to 6 months, 6 to 8 months. Today they are asking for 12 months. That is what is the evolution all about.
Right.
And that gives them such a high cost saving factor.
Right.
Ki changing of a liner after 6 months, and then we evolve to change after 10 months.
Wow.
And then we evolve to change after 1 year.
Right.
It cost them nothing,
Right.
actually,
Right.
compared to the downtime losses that they have faced by loss in productivity. So you can imagine the cost of productivity. If
Right.
a company like Tata would be doing a business of almost, say, 3,000 crores a year out of this ore, just mining. And if you divide that 3,000 into 300 working days,
Right.
so that is the type of per day cost to the company.
Right.
And I'm talking about crores and crores of or dollars
That could be
or
saved.
millions of dollars can be saved by just using the right liner.
Right. Right. Yeah, I mean, steel is definitely essential, right? Like I think before the discovery of steel, I think all that was used was wood, and then I think eventually after they discovered steel, now I think from our cars to our mobiles to everything is using steel, right? So I can definitely understand why productivity would play such a key role in this industry. These liners that you manufacture, what sizes do they come in?
See, they are standardized based on portability, or you can use the word how accessible it is for a human to carry it and put it across.
That's the way it's been designed. Or standardized, you said, right?
Standardized.
Right.
So 20 kilos is considered to be an okay safety factor for 1 or 2% to carry it and put it in place.
Right.
They have 2 bolt arrangement where the bolts, I mean, you use a nut and lock it.
Okay.
And it is basically having a complete brick pattern.
Okay,
Or
got
a
it.
segmented pattern.
Okay.
And that is a standard size of a liner, which could be about, say, 440 or 400 by 300
Right.
millimeters.
Right.
The thickness could vary right from about 15 millimeters to about 40 millimeters.
Right.
Now that depends upon what kind of protection the customer needs and what is the life factor that they're looking for. So to answer this question correctly, we are now graduating more and more into the liner management business.
Right.
So what we have realized in this course of time, that if we can calculate the exact CFD, that is the flow diagram through a computer aided program, we can exactly predetermine and predict the life factor and how the wear is occurring.
Right.
So once we now know that the wear is occurring in this particular angle of impingement,
Right.
where the fall is coming or the exact point of load is coming, from that angle of impingement, if we calculate about say 20% down and 40% up,
Right.
if this area can be protected with a very high ceramic liner, which might cost you a little dearer, but the life of the complete transfer or hopper can be avoided,
Right.
and that can be enhanced, and the rest of the part of the same hopper liner can be reduced by using little cheaper material.
You can balance it out that way.
And that is where we are now coming from.
Basically like a tailor-made solution.
Tailor-made, it's called the liner management technology.
Okay.
By which the software can determine this particular thing. And making it into this kind of a mosaicing, like 150 by 150, instead of having a big liner, what we can do is we can easily replace it within a short span of time by making this management services available to the customer.
So you're saying that by identifying the wear pattern or sort of the point of contact of or the area where wear is occurring most, you are able to then go on to install more heavy duty liners in those regions, because that is where more wear is happening, and then in the other regions you can install a little cheaper liner, and that's how one way to maybe balance
it is
the
not
cost.
heavy duty, it is more metallurgically correct solution.
Right. Okay.
So the world is going more and more towards ceramic and ceramic composites.
Right.
The ceramic and ceramic composites are very light in nature.
Right.
Because the density is not exceeding 3.5 grams per cc. So if you compare a metal liner which is almost 7.99 grams per cc, you are reducing the weight by almost 40-50%. And the wear pattern, the wear analog is much higher and better, because the ceramic to a ceramic, cermat, is what the solution should be. Like our teeth, it is made out of ceramic.
Right.
So the ceramic is crushing all your bones and your
Everything.
food stuff.
Right.
Why this was not given as a metal? That is a question that you have to ask.
Interesting.
So it is basically the cermat, or you can say the ceramic or the earth material is helping to crush another earth material, earthy material. जैसा लोहा लोहे को काटता है.
Right.
So you have to understand, you have to add an antidote which can kill that poison.
Right.
So that is how the evolution is now taking place. Previously, we were not able to make these ceramics so hard and strong into a metal.
Right.
Today, the technology is going towards that, where the ceramic can be embedded into the metal.
Right.
Or it can be fused to a metal.
Right.
Even though the density is very low.
Right.
So the surface where it is getting subjected to the wear, it is made out of ceramic. And that is giving you an excessive life factors.
Right.
Compared to the old liners and its management.
Like you said, you mentioned something about a liner management system. So liner management system not only helps you, how would a liner management system help you in the maintenance part of things? One is the selection of the liner, and then also the maintenance part of it.
So if you look at the preventive maintenance, what we can do or what is happening right now all over the world is that they are able to insert sensors,
Right.
and these sensors can detect and predict the wear based on certain logarithms.
Right.
So if you collect a 3-year data and limit your logarithms, ki this is what is the range that I'm looking for in this particular liners,
Right.
which are subjected to this high wear,
Right.
we can easily get it transmitted through a modem
Right.
to a particular GSM, or you can say a computer,
Right.
and it easily detects
And
It can be
notifies.
stored in cloud also.
Right.
So these predictive measures are becoming more and more common and easier in case of such liners which are now coming in the market.
Right.
And it is very, very predictive, because once we know that this is the prediction, the chart starts measuring it in real time. So the real time value is almost in seconds.
Right.
Whereas in 6 months we used to open it up to see whether it is worn out or not.
Visually.
Visually. And that is also not correct, because there is a
Right.
human error in it.
Right.
Today, when we know that these predictive measures are already there, and the logarithm is already fed for this particular
Right.
transfer line or shoot, we can easily tell that next 2 days or next 3 weeks you have to change these liners.
Right.
And we are looking at that as a objective to serve the customer with that services also.
Right.
So we not only give you a liner, we not only give you the right liner management, which liner to be used, we also giving you a predictive wear, and we are also giving you 24-hour service.
Right.
So what is invariably happening is that we buy back all the liners back from you,
Right.
and that becomes a sustainability, because we
Right.
can always recycle to use it back for you.
I see that you've brought a lot of samples with yourself. I mean, can you explain or can you tell us and show us a little bit about the different types of liners? What is this liner called?
It's called Super High Life.
Okay.
High Life, see, this is a brand name. The Super is a brand name.
Right.
And why High Life? High Life is this because what happens is this, that we make this out of sintered cast process. These liners consist of carbon, chrome,
Right.
moly,
Right.
percentages of some nickel,
Right.
and all these are composed in a electric furnace, and then they are put into a die and compressed and made. Now the question is this, that as we are a metallurgical based company, finding a solution and giving a recommendation is very similar to what a pharmaceutical company is to human body.
Right.
So if you are suffering from any kind of fever, I shall be giving you a specific paracetamol.
Right.
But if you have a stomach problem or acidity problem, then I'll give you a medicine which is related to your stomach
Right.
acidity
Right.
solutions. I cannot mix these two. So the paracetamol becomes the family of cure for any kind of fever.
Right.
But when you go deeper and deeper into it, that particular family changes the chemical composition based on what the problem is. Similarly, in our metallurgy,
Right.
chromium carbide is supposed to be a very, very common formula
Right.
for most of this medium abrasive, medium or high impact problems.
Right.
The only difference is this, that how nano can you go into these particles to have a much better surface quality,
Right.
and that gives you a better density,
Right.
and that gives you a better wear property.
Right. So no cracks.
No cracks,
So I think the problem
no
with the
lean mean path,
Right.
proper structuring of your carbide,
Right.
content of carbide contents are higher. So if you see any of our Super or Imco products, you will always get the hardness measured in thickness.
Right.
And it will be the same.
Right.
Whereas any kind of welding or any kind of other process of making a wear plate or something, it is only in the surface. So the dilution takes place only in the surface.
Right.
So the first 3 millimeters you will have the same hardness.
Right.
But as you go deeper and deeper, you will always differ into
varying hardnesses.
varying hardnesses.
Right.
So indirectly what it proves metallurgically is that very similar to red blood corpuscles and white blood corpuscles. So the red blood corpuscles are very few in numbers, but they fight, the white blood corpuscles fight the disease first.
Right.
When they can't do anything, that time the red blood corpuscles comes to your use and it fights the fever out.
Right.
Similarly here we have primary and secondary carbides. And the formation of the carbides gives you an exact red blood, how many red blood corpuscles and how many white blood corpuscles are there.
Right.
And that comes through vacuum.
Right.
An absolute inert atmosphere where there is no contamination,
Right.
there is no nitrogen, there is no hydrogen embrittlement, which are all exposed by welding or any kind of wear plate manufacturing. So this
So
is
any kind
why
of welding or any other alternate process could not match. I mean, today in 2024 could not match up to the process that we're following.
you can see this surface also.
Yeah, very smooth.
There is no crack.
No cracks. Yeah.
You can see
No
the
dilution,
quality.
yeah.
You can see the lamination.
Right.
Absolutely is fine, 0-0.
Right.
And if you check the hardness from the top surface to the bottom will be the same.
Right.
So this itself proves.
Yeah, very good finish, very
correct,
smooth.
Correct.
So it does the. I mean, I'm just out of curiosity. Does the smoothness play any role in?
Oh yes, highest coefficient of friction.
Okay.
So as you increase the coefficient of friction, what happens is that the material is not sticking into it. It is just sliding out.
Right.
So the contact between the material and the
Right.
plate is the least.
Right.
That is where the smoothness, stickiness, then it leads to the stickiness leads to
carry bags.
Carry bags.
Right.
It gets stuck and then it becomes hard. The
Oh,
volume
right.
of the pipe decreases.
Right.
It's very difficult to remove it later.
Right.
And why is it happening? Because it's all getting stuck into the surface.
So then previously you said there were certain other applications they were using before liners were the more commonly used solution. So in the previous solutions, let's say like welding, what were the issues that they were facing?
So if you take, this is a clad plate.
Right.
We do sell clad plates also.
Okay.
But this
Can you
is an
explain
old
what a
process.
clad plate is?
Clad plate is like you take a mild steel plate.
Right.
You fix it in a particular fixture.
Right.
And then you have the welding torches. The welding torches basically starts depositing the weld beads.
Got it.
And then it reaches to a very high temperature of
Right.
welding. And then from the flux, the carbide comes and starts falling down.
Right.
And then it gets distributed all over.
Okay.
And as soon as it cools down, the stresses that are developed due to that high heat reach to these cracks. You can see all these multiple cracks.
Okay. Yeah, a lot of cracks.
Now these cracks are very, very harmful for the wear pattern, because from these cracks, through these cracks, the abrasive media enters. And then it starts ripping off the surface.
Starts wearing or degrading the surface.
And you can see this has got no cracks, uniform
So-
hardness. And all.
I mean, is just so as a business, wouldn't welding be a better solution because the mines would just need to? As a business, wouldn't well-clad be a better solution because the mines would just have to keep buying it and keep purchasing it again and again?
Yeah, for the welding companies, yes.
Yeah, I
But
mean,
not for the mining companies.
not for the mining companies, right? Yeah.
See, there was no solution previously.
Okay.
See, I'm talking about how it was getting the evolution has taken
Right.
place. We also make this hardox plates.
Okay.
So this is one of the first
Right.
invention.
What is the name
It
of
is
it?
we are using it as Super Tough 400,
Super tough.
and hardox is a brand name.
Okay.
So it is called quenched tempered steel.
Question tempered. Okay.
So what used to happen is that they used to take a quenched tempered steel and then give a heat treatment surface to it. So the top surface gets a hardness of say about 40 RC or 35 HRC.
Right.
And that is only in the top, maybe about 2 or 3 millimeters
Right.
on the top.
Right.
But there was no other solution for it. So they still sell. We also
Right.
make.
Right.
But this is now being a very moderate impact, very moderate abrasion solution. Then came the wear plates, the weld-clad plates. Good. But the cracks, the indulation of welding,
Right.
the up-down led to all the
Right.
sticking effect, cracking effect, breaking
Right.
of this.
Right.
Hardness was not uniform. But 60 HRC, and then this wear out was much faster.
Right.
Then came the sinter cast process,
Got
which
it.
again used the most of the compressed part, very
Right.
high density, very clean atmosphere, inert, in vacuum. After this, the evolution started. Then we started with the ceramics,
Right.
the embedding of the ceramics.
Oh, okay. So these are ceramics, huh?
Yeah, so you can embed them in metal. So these
Okay.
are the metal carbides in which
So
the ceramic
why ceramic specifically?
So ceramic is, as I told you, it has much higher hardness than any of these metals.
Okay.
Number one.
Right.
Number two, the ceramic has got a very high property of abrasion. It can withstand very high abrasion.
Oh, it's abrasion resistance, huh?
Abrasion resistant. Even in ceramic, there are 2-3 different types of ceramics. Now, what has happened is that these ceramics are basically fused but not infused. So, the development came to the fused ceramics.
Oh.
Now, you have the ceramics which are fused in metal.
So what about this? What is this?
So, these are
The super hex hybrid. Huh?
So these are basically polyurethylene materials,
Okay.
very light,
Right.
and we are able to embed the ceramics inside.
Right.
Now this has a different application altogether. So these are used in wet condition where the temperature is below 60 degree
Okay.
and it is the slurry and all these kind of things which gets mixed while conveying the material. So these are very effective, very light, and very in low temperature. This works excellent.
Okay.
The ceramic is the one that takes care of the wear items.
So these liners that you just showcased, I mean, there's a lot of them. What are the major ores where these can be used? I mean, in which kind of ores are these types of liners used?
Most effectively is copper,
Right.
or you can also use nickel. These are the two very highly wear-prone mines.
Right.
Copper, because as soon as it gets exposed to atmosphere, it oxides. So there is a huge corrosive wear that takes place
Corrosive wear, huh?
on these liners.
Right. Right.
Even gold is very, very abrasive.
Right.
There's a lot of wear and tear that takes place. Diamond, lithium,
Right.
nickel, copper,
Right.
and then comes this iron ore and coal. But if you look at a global market size, iron ore and coal is the maximum
Quantities.
quantity wise.
Right.
Of course, these copper mines are there, but they are very specifically in certain areas like Chile, Zaire. Then
Right. So even though you cater more to, let's say, iron ore or steel, these would be very. What do you mean to say that these would be actually more helpful in copper and these more extremely abrasive ores?
So, but because the quantum of tonnage of iron ore is much higher,
Right.
or you can say coal is much higher
Right.
than copper mines or it is limited to very specific mines
Right.
like Canada or Brazil
Right.
or Peru,
Right.
Chile.
Right.
So,
So are you already supplying any of these liners anywhere?
oh yes,
Okay.
oh yes.
And what has the performance been like?
There are some very good performance. The ceramic liners are outperforming
So when you say ceramic, you mean
this and this
these particle ceramics?
particles
Okay.
plus solid ceramics
Okay.
plus these ceramics.
Right.
They are outperforming metallic liners.
Right.
Then, as I discussed with you, that the liner management program,
Right.
where we know exactly where we should be putting, so we can go for a choice of putting these liners in very specific areas. So definitely the ceramic and the composite ceramics are outsmarting the metal liners. And I feel that the future is going to be more and more of ceramics.
It's going to be more in the line of
Yeah,
ceramics. huh?
composites
Right.
and ceramics.
Right.
Composites mainly because the weight is getting reduced to half. Secondly, they are very, very high abrasive technologies. People, the liner management
Right.
as a program
Right.
is becoming more and more workable because
Right.
the material is becoming lighter and lighter.
Right.
So the downtime, changeover, manpower,
Right.
everything is getting reduced.
No, I think this whole part about the liner management system and how this can sort of be integrated to have that predictive maintenance capability is really interesting. But do you think that let's say we speak about the steel or the mining industry, not mining but specific to iron and ore and steel. Number one is what are the challenges you face while implementing such futuristic projects in these industries? And number two is that are they open to adapting these kind of changes? I mean, is it a cost conscious industry where, let's say, I'm sure the ceramics and all wouldn't be as cheap as maybe using a simple well-clad solution, right? So even though they might perform better, as an industry, what are the challenges that you have faced to get them to adapt to these newer liners?
See, it is very simple. I mean, you have to evolve with better and better material.
Right.
And initially, the better and better materials cost more because the consumptions are less.
Right.
People awareness are less.
Right.
But people who are using it and they can see an ROI on that compared to what losses they would be make on a shutdown on a totality, they have already started shifting their base. Especially the private players.
Right.
Okay, because they have to prove P&L.
Right. Absolutely.
And they know that by spending 2 rupees more
Right.
or 10 rupees more,
Right.
if they get even 2 days or 5 days or 1 month more life,
Right.
you can imagine the productivity
Right.
cost.
In
So-
crores, right?
Yeah,
In crores.
it's
of
in
rupees.
crores.
Right.
So basically, there is no need for the industry to worry much about what is our cost.
Right.
It is more of the solution that we are giving,
Right.
which is enhancing their life factors,
Right.
which is running in crores.
Right. Right.
And of course, we are proving a pro rata life factors compared to what they are using now. And
Right.
it is only after proving to them that it will work 1.5 to 2 times more than what you're using,
Wow.
the customer is getting convinced.
Right.
There is a case in NMDC, I'll just tell you,
Yeah, please.
where a manganese steel liner, which is a very traditional old liner,
Right.
would work for 2 months.
Right.
That could be roughly around 3,000 or maybe like 5,000 tons of crushing. Today, we have crossed almost 1.5 years with 10 lakh tons of crushing with ceramic liners. So the customer is also very confused now.
It's more than 4 to 5 times.
No, 400 times.
Yeah, 400 times, right.
So, what is important to understand is that you do pay a little more,
Right.
but then you do get a much, much better life factors.
Right.
And that is in everyday's.
Absolutely, right. Like, so many times we face these is that it's like, simple example would be like you buy earphones from a railway station
Correct.
and then you buy maybe a decent pair of earphones, right?
Correct.
You wouldn't have to replace these for years, but the ones you buy from the railway station,
I mean, for example, this is a patented product of Imco,
right?
and the composite ceramics induced into metal.
Right,
This must have taken us at least 7 years of research and development.
right,
So you are paying more for research and development by a company who is catering for your requirement, your needs. We are a company who is giving you the solutions to make your life more easier. Don't drive me away. I mean, which company would spend so much on R&D to give a solution to your problem? So definitely we are here to stay. So that
Right.
has to be appreciated.
right. Definitely, definitely.
Once that is being done and understood, of course we are also making our money, but then we are spending that kind of money also for R&D.
Right, right, right.
It doesn't come
Right.
free. It comes at
Right.
a cost actually.
Right, right. And I think that applies to most
Everything,
most products
every
that you see
technological
around
products,
yourself
yeah.
also, right? What are they actually really
Yes.
charging you for is
Yes.
the years of effort it's taken to sort of
Correct.
build that product, right? I think it's really easy for companies to ignore that cost. I mean, time cost, effort cost, as well as financial cost that goes into developing these products as well, right?
See,
I'm sure.
absolutely.
How
I
long
mean-
has this process been to develop these liners? Since when have you been working on?
I mean, I think it's been almost 20 years.
Right,
And then, of course, we were in the smaller scale.
right,
But today we have a spectrum of product to be put into the use. And with the software and the liner management programs, with this, we are very confident that we can give a very good solution to that particular wear that is happening. Now the point is to identify that particular wear. It is not
Right.
the whole.
It's not a one
area
size
to
fits
be-
all
Yes.
type of a solution. So you guys are completely made in India, or
100% made in India.
okay, okay, okay,
In fact, we have our exports also to countries like
Wow.
Australia, Russia,
Right.
Africa,
right,
Malaysia, Indonesia. Things are
right,
moving. Actually.
right, right,
So, our main aim and a goal is to get into the liner management program, where we can design an entire chute transfer line or a hopper based on the technology and the predictive wear, and give the solution where the services are also given by us. Change the liners for them in a record period of time by our own people,
right,
and if it gets completely worn out, take it back as a
refurbish it,
sustainability program where
Right.
we can recycle the full thing
right,
and give them the value,
right, right, right.
give
Like-
them back the value.
Right, like a complete package, a complete solution is
package,
what
yeah.
you want to offer.
Yes, yes.
Right. What made you think of, or what was the need of getting into something like a liner management system? I mean, what was the loophole or the drawback that you identified in the industry that you wanted to then pursue
A
this?
good question. See, what we analyzed is this, that the customer is so used to changing liners through contractors,
Right,
and invariably about 8 to 10 millimeters of wear happening in one particular area, the entire liners are just thrown out.
right,
You can call it a human error,
right,
or you can call it that the customer does not want to waste time by reusing and segregating these liners. That is one. Secondly, what we are observing as the time is evolving, there are so many products that are now coming in as a liner management. The customer is still used to that old technology of putting the same liner all over again. And they got so used to it that every 15 days or every 1 month, they will shut down and they will change it. So the education to the customer on this particular basis is also not there.
right,
So first and foremost, we really need to educate the customer ki what exactly is this computer aided flow diagrams, how it aids us, how the preventive maintenance software is aiding us. How the technology is evolving based on the new materials that are coming, advancements that are coming. And what would be the future of this particular thing? As a whole, there is nobody who's working only on this subject. So the customer is not aware of it. So he ends up buying an A item and he keeps on changing it every 2 months. And who is doing that? Lower down people who are contract people.
Right.
And they are very happy to change it because that is where they are making their money.
Right.
And the customer is losing money on throwing away everything, which is such a resourceful material.
Right.
Which can be easily recycled
without
or
ever identifying the wear pattern.
Without identifying the wear pattern. Without understanding exactly. I mean, it is very challenging for us to also explain to the customer who would say that for last 50 years I am doing it, so don't teach me all this.
Right. Yeah, it wouldn't be the easiest. Yeah.
It is not easy.
Right.
It is not easy because he has got used to a certain pattern of working, and it is very difficult to change that pattern.
The only kind of, let's say, I mean, today currently, the only kind of inspection that is happening is only visual inspection.
Yes.
But from what I'm imagining, a chute or a hopper, isn't visual inspection very difficult in such situations?
See, it is not only difficult,
like
there is no way that it can be ascertained.
Right.
Like exactly how much wear has taken place in the entire line.
Right.
So you can imagine that one straight line has gone out. But what about the 70-80% of the other liners?
Right.
So what if happened if we could have changed only this liner?
So they will change, even if one side is gone out, they will just change all of it.
It is a very difficult subject on the ground that it has not yet been taken up so well.
Right. One company focusing only on
that.
Right.
And when we are doing that as a only focus point for us, and if we are not encouraged to that,
right,
one day we give it up.
Right.
Because you are doing your R&D research, everything based on only that focus area. We don't know how they make the steel. Neither we are interested in.
Right, absolutely. And I think that is a part, their focus is more on the steel making.
Correct.
Right, not so much on the procurement of the ore.
Correct.
I think a similar observation sort of, or a key point stood out when I was having my conversation with with Mahesh from the sugar department, where we sort of identified is that the cane department is responsible for the timely payments, the on-time delivery of the cane, the transportation, and so, right? And then you have the factory manager, the chief engineer, who are responsible for the sugar cane crushing or the preparation, right? So there is no one team that is sort of bridging the gap between these two teams. Both the teams are really occupied, so there's no one really bridging the gap between the cane department as well as the factory manager. So let's say there are changes in harvesting methods that have happened in the cane field, where now you have moved from a manual to a mechanical, but preparation hasn't changed one bit. Right, so somewhere where he was also talking about Imco Alloys being that one player that is sort of focused on bridging that gap between these two departments and taking charge of making sure that these advancements that are happening on, let's say in your case, the mining side is also, benefits of it are also felt in the preparation side, right? In a certain way, the more, the better they break down the ore, the more steel they're able to make, right? So I think aren't these two completely interrelated in the sense that, let's say if I have a lot of shutdowns, or I need to keep changing my liners or my chutes. Obviously, there's one thing that the cost is going up, but I'm sure this also affects the steel production as well, right?
100%. See, the requirement of steel in this country is much more than what the production is.
Right.
And for them to have no material in time is a huge loss at the end of the steel plant.
Right.
So you can imagine the complete continuous flow of raw material, the iron ore material going back to them.
Right.
Secondly, these liners play a very important role in flowing of the material in time. So the sticking effect is an entire loss to the company, or the holes and everything.
Got it.
So if you put that all put together, even 1 to 2% losses which are occurring because of a wrong liner is a huge amount at the end of the year. Huge amount. You cannot imagine, because they would be mining somewhere on maybe easily about 10 to 12,000 tons per day.
Right.
Or maybe even 20,000 tons a day.
Right.
And out of 20,000, if 2% is a wastage, which is getting stuck because of all this reasoning of using a wrong liner.
100, 200 tons.
That is 200 tons.
Right.
So you multiply 200 tons with the cost of steel today.
That's the loss.
That's a loss.
Absolutely.
That's a straight loss.
Right. Number one is the loss because of the downtime, and the loss is also because
Absolutely.
of the continuous buying inventory of these
Absolutely.
liners that they are also
Absolutely.
holding, right?
And okay, fine. Here, if you take Tata Steel, for example, they have an in-house usage of the
Right.
iron ore.
Right.
But what about companies like NMDC? They are exporters, the largest exporters. For them, 2% is a straight net loss.
Right. Right.
Because there is zero recovery in such cases.
I mean, they are not forward integrating. They are not making a product out of it. They are
Correct.
straight away just exporting the steel, right?
Correct.
I mean, with Tata, I mean, in the case of Tata's, because they can use it to
make
make
the
cars,
steel.
they can make the steel as well, right? So
there is a loss even for both the companies.
Right.
There is a downtime which is very heavy, and there is a carry forward which is going on.
Right.
But the main goal for all these people is to reduce losses.
Absolutely.
I mean, when can they come to zero losses without using a proper software, computers?
Right.
That is what we have to
Right.
look into now.
Right.
That is what is the high time that we start looking into it. Can humans be so accurate, or we need machines to operate these things in a much...
Yeah, I mean, do you think that this has something to do with labor being cheap in the country? I mean, that our adaptation to technology is much lower?
See, the most foolish part in India is to calculate labor cost without calculating the losses of the actual production. What is the cost of labor in India, and why are we so happy about it?
Right, interesting.
You know, why are we so happy about it? Because we think that apna paisa kam gaya. I just paid 100 rupees to that guy.
Right.
But what about the productive loss that you have done at the end of the day? That is in crores.
Absolutely.
So you are basically being a penny wise pound foolish.
Right.
And you are very happy about it because वो मेरा कोई लेबर लगता नहीं है यार, दो चार आदमी का क्या फर्क है? अरे दो चार आदमी का बात नहीं है, तुम्हारा जो डाउन टाइम हुआ उसका कौन कैलकुलेट करेगा?
Right.
Have you understood them? So certain sentiments even today in India are so funny that the West has learned very well out of it by understanding the productivity is much more higher than the cost of manpower.
Right.
Just because we are a populated country, that does not mean that the manpower is coming cheap. They are not cheap.
Right.
They are ineffective.
Right. And that's why you need more people to do one task.
That ineffective person is removing all the liners and throwing it out.
I get you, I understand.
You understand what I'm trying to say?
Right.
So if you look at it in an overall perspective,
right. You're not really saving anything.
You are not only saving, you are actually losing.
You're actually losing, yeah, right.
And
yeah, I think it's that typical
owner-centric point.
Absolutely,
a Marwadi company would not do that.
Right.
He would always see to it that.
Yeah, I think it's the common way of dealing with things is that okay, I'm just going to put more people on the job. You know, instead of hiring one competent person and paying him 1 lakh, I rather hire 4 people and pay them 25,000. You know, correct. I think I think that has to change just because we have so many people.
And with
effectiveness,
AI coming,
right?
And we have such a nice AI ML, that is artificial intelligence, machine learning.
Right.
That AI ML software itself is giving you all the data in real time. That is almost like your heart getting measured in seconds. So if you can measure it in seconds, why do you need a human who will open up every month or every 6 months to tell you that Saab ghas gaya.
Right.
Saab nahi ghasa.
I'm sure
I
machines
think
are more
that
reliable.
that is the manipulation.
हाँ.
Saab ghas gaya. Acha nikal do.
हाँ.
Why?
Right.
So it's a question to be debated and understood.
No, I think one other point you said is that it's, like when you said that the change of these liners and all of this is a very owner-centric point, right? The owner is the one that is going to be directly attached to the profits that the company is making. But whereas I think as you keep moving down the chain, people are less affected by the profits and more to do with that, just their day-to-day task.
I feel that what happens with the top management is that they are more scared to have a breakdown than to have a complete changeover done faster. Plant should be running. Plant should not shut. So what happens in that bargain, all these liners or something get changed faster so that they don't get that risk of having another wear problem occurring. But if it is studied in a proper manner,
right,
and if you can do the exact logarithm with your study, you will come to know that if these liners are removed, then it can be put lower down in some other areas.
Right.
But who is going to do that?
Who's going to do that?
Because again, manpower is a problem. But what happens if this becomes our business and not your business?
Right.
Your business is to make ore.
Right.
Like the sugar guy, his business is to make sugar.
Right.
His not business is to see to it that all the equipments are running
the
properly.
material used in the equipment, the chemistry of the materials used in the equipment is not his job. Right, but yeah, but you also need him to be open to the solution, right? If like you were saying,
that is what will come in the course of time.
Right.
That is what has already happened in the West, where there are no people to work.
There aren't, right? And you can see how that has driven efficiency as well, right?
Correct.
You have
Absolutely.
Where now in India we are just adopting mechanical harvesting techniques, might be 20% of the entire pool, whereas in the West it must be upwards of 50-60%, right? Because there's no people, so efficiency has always been driven in that sense, right? So I think
the positive side about having people is that we can utilize them to do some softwares for us.
Right.
And the negative side of it is that we use this lower down people to work for us, thinking that they are more effective, productive, but they are not.
Right.
They are not.
Right. Yeah, and there isn't any point if you hire someone and you need to do their part of the thinking as well, right? So, right. Yeah, so I think, but do you see these things changing in the future?
Yes, of course.
I think Imco has been in this industry for more than 2 decades. So I'm sure you yourself, being the founder of the company, have you already seen a shift from, let's say, the 2000s till now 2024?
Yes, of course.
Yeah.
Of course.
Okay.
The process of educating and education, presentations, bringing in new technology, showing it to them. There is a lot of shift that is happening.
Right.
The problem, or I can say the identification issue, is this, that because we are in the field, we are not able to see it. But someone from outside can easily come to know how India is really graduated and learning to become better and better.
Right.
So India is a manufacturing hub.
Right.
And a productivity hub is what we should actually foresee for the next 10 years.
Right.
What exactly happened to China?
Right.
This is exactly what India should grow into, because with so many people around, we are very unproductive.
Right.
Because there is no good training done to them.
Right. Then again, it boils down to a grassroots level of training people and having more skilled workers, right?
Correct.
I think even with when Apple came to India and they were sort of assembling iPhones in India as compared to China, the rejection rates that they were having, or the rejection rates that they were facing in India were significantly higher than what they were seeing in China. I've never been to China personally, but from what I hear from my peers and people in the industry is that that the rate of defects or the manufacturing or the skilled labor that they have is really much higher than what we have here in India. So I think that's maybe, I think training programs and certain other things are where we should aspire to be. Do you guys run any type of training programs? I mean, at
Yes,
Imco
we
Alloys?
have our own training center.
Okay.
So we try to have these kind of courses from time to time for all our sales engineers,
Right.
for our welders, for our supervisors, quality control.
Right.
We have our regular QC plans,
Right.
ISO programs.
Right.
Then, I mean, these are all so subjected
Hmm,
to training.
Right.
Because the entire model of business is to educate your people first so that the Xerox copy is better. So unless he knows what we are talking about, it is not easy to recommend products where these are all highly recommended products to the customers.
Right.
Because
Right.
he should know which to recommend where.
Right.
Otherwise, it could lead to disaster also.
Right.
A wrong
Right.
product line is a disaster. So it's a very challenging part for us now. But I think we spend and we budget a lot of money into training these boys and all that from time to time.
Right.
From time to time.
Right. So yes, since this is such a niche field of work, I mean, can you tell me a little bit about how you got into this field of work?
See, basically, my background started with Larsen and Toubro,
Right.
where we had a division called as UTech Tech
Okay.
division, which was dealing with very specific alloys, that is, the welding alloys, to give solutions to repair items which gets worn out.
Okay.
So it was basically a salvaging program.
Right.
So all these costly items which gets worn out,
Right.
we were taught to weld them in such manners
Right.
that it can be salvaged.
Okay. Got
So the cost of reclamation,
Huh.
the cost of salvaging,
As compared to replacing.
in place of placing,
Ha.
was the key factor where most of the Indian people adapted to this salvaging processes because they were cheaper
Right. Right.
than to buy these expensive products from abroad and all that. So in our time, most of these steel plants, cement plants, we always used to get products from Germany. And Germany was a key in engineering. And it was very, very expensive to buy these products from Germany.
Imco Total Wear Solutions.